Good morning students, welcome to ABN and PRR College online classes. Today we will discuss one more application of monotone convergent theorem. Here the sequence is given as a1 is equal to 1 and n plus 1 is equal to 2an plus 3 by 4 for every n more than or equal to 1. Now we want to prove that this sequence is increasing and is convergent, and also we want to find its limit. Okay, right. Such kind of sequence is called iterating sequence because the terms are depends on previous terms here. Observe that given sequence is a1 is equal to 1 and an plus 1 is given as 2an plus 3 by 4. From this we can obtain remaining terms of the sequence. By putting n equal to 1, then we get second term of the sequence. What is this value? 2 into a1 plus 3 by 4. What is a1? Here 1. a1 value is given as 1. 2 into 1 is 2, 2 plus 3 is 5, 5 by 4. This is the second term. By replacing n is equal to 2, we get the third term of the sequence in the n plus 1th term. That is 2a2 plus 3 by 4. What is a2? 5 by 4 plus 3 by 4. 2 to cancel. The value is 5 plus 10. 5 plus 6 by ఓవరాల్గా మనం కామన్ తీసుకున్నట్లయితే 11 by 4. 4 into 2, 8. And so on. Which means that here we observe that the terms relation a1 is less than a2 is less than a3 and so on. Okay. We don't know the remaining terms. That's why we can use induction here. Clearly here, first term is less than second one. Let us suppose that this is nothing but induction supposition or induction assumption. AK is less than its consecutive term AK plus 1 for K being any positive integer. This is the induction assumption. Now let us make left hand side it as AK plus 1th term and right hand side as its consecutive term. Okay, for that I want to multiply this inequality with 2. 2 is a positive quantity. There is no change in this inequality. And adding 3 on both sides. There is no change in the inequality because 3 is a positive quantity. Now multiply this inequality with 4. 1 by 4. Then 1 by 4 is a positive term. There is no change in the relation. 1 by 4 into 2ak plus 1 plus 3. Now observe that. What is this value? 1 by 4 into 2ak plus 3. 1 by 4 into 1 by 4. Now observe here. 1 by 4 into 2an plus 3. This value is an plus 1. Like that, here the value is ak plus 1 is less than ak plus 2. That means by the method of induction, we can say that smaller terms of the given sequence are smaller than bigger terms. That is, we can easily confirm that for every n, our sequence terms are obeying the condition is this. Therefore, our sequence n is increasing. It is an increasing sequence. That means it is a monotone sequence. When we say that increasing sequence is bounded, Obviously, by birth property of increasing sequence is bounded below nature, and we want to prove that it is bounded above. Coming to the case 2, we want to prove that sequence is bounded above. Again, we will prove this by using method of induction. We have, what is a1? It is equal to 1 given. Obviously, this value 1 is less than 2. Now, let us assume some kth term of the given sequence is less than 2, for k being a positive integer. Induction assumption is depends on first term. First we want to prove the given statement is true. Next assumption. Induction method consisting first, let us prove for first term. Second point is that assumption. Finally, by using assumption, we prove the same condition for all terms. Okay. For that, let us make left hand side as ak plus 1 వచ్చేలా అరేంజ్ చేద్దాం. ఫర్ దట్ మల్టిప్లై బోత్ సైడ్స్ విత్ 2ak 2 and 2 into 2 is 4. Now change in the relation. Adding 3 on both sides, no change in the relation because 3 is positive. Multiplying with 1 by 4, no change in the relation because 1 by 4 is the 3, 4 plus 3 is 7. 1 by 4 is the positive quantity, so no change in the relation. That means, what is this value from the given sequence notation? This is the ak plus 1. Ak plus 1 value is now less than 7 by 4. 7 by 4 means 1 point something. Obviously, it is less than 2. Now, observe that when we assumed that kth term is less than 2, we proved here next consecutive term is also less than 2. This being true for all terms by using method of induction. Therefore, all terms of the sequence now less than 2. Therefore, 2 is an upper bound. Upper bound exists only whenever it is bounded above. Therefore, our sequence an is bounded above. Is nothing but increasing sequence bounded above. Is nothing but bounded sequence. Bounded sequence. That means our sequence is monotone and is bounded. Hence, by monotone convergent theorem, our sequence an is convergent. Okay. Suppose that this sequence is converges to L. Then what happens? Limit of the sequence when n tending to infinity is L. Whenever nth term is tending to L, obviously next terms also tending to L. That means limit of an is equal to limit of an plus 1. Question is asked to find L also. So let us replace the value of an plus 1. What is an plus 1? It is given as 2an plus 3 by 4. Coming to the right hand side, let us simplify this. 2an by 4 plus 3 by 4. A plus b by c can be written as a by c plus b by c. Using that rule, we can split. Now, limit is split to 2 terms because limit of a plus b can be written as limit of a plus limit of b. Also, we know that limit of a constant is constant. These limits are when tending to infinity, which is equal to, taking outside 2 by 4 because it is a constant, into limit of an plus, what is the limit of 3 by 4? Because 3 by 4 is a constant limit is the same constant. Now, let us replace the limit of the sequence an in both sides. What is an limit here? L. That implies L is equal to 2 by 4 into this value is L plus 3 by 4. common 1 by 4, then we have 2l plus 3. Multiplying entire equation with 4, we get 4l is equal to 4 by 4 get cancelled, 2l plus 3. Taking to left, 4l minus 2l value is equal to 3. That implies 4l minus 2l is 2l is equal to 3. That implies l value is equal to 3 by 2. That means our sequence, the given sequence an is converges to 3 by 2. Okay, this is the answer. Thank you.